you are comparing two samples and find a difference in their means equal to 8 points. So let's say, for example, I've got a mean of 100 and another mean. This is for my first group. For my second group, I've got 108. So these are 8 points apart, the two means. Provided that these samples both have the same variance, so they both have the same amount of variability, which of the following values of that variance would best allow you to spot the difference between two side-by-side plots of these distributions on a graph? Okay, so let's have a look at making two side-by-side plots. Let's take, let's create sort of a number line. Actually, I'm going to do it like this. I'm going to have, let's call this 100, and I'll go up by 2s. So 2, 4, 6, 8, 10, that's 110. 2, 4, 6, 8, 10, that's 120. All right, and let's go back a little bit as well, or maybe I should go up a little bit further. Oh, that's good enough. Let's go back a little bit as well. 2, 4, 6, 8. Okay, that should do it for our purposes here. Okay, so not exactly a perfect scale, but this will sort of help to illustrate what they're talking about here. Now, we need to have two different means. So I've got a mean of 100. So here is, I'll put on this side my mean equals to 100, and on the other side I'm going to have my mean equals to 108. Now they want to know which variance, if these both have the exact same variance, which variance out of these ones listed here is going to make it easy to spot the difference between these two distributions. And these are just the means, or the centers of the distributions. So these two distributions side by side. Okay, so let's start off here. Let's start off with the very first one. I've got a variance equals to 3. Now if you ever want to try and use a visualization like a number line, you shouldn't use variance. Variance measures squared variability. It's a version of variability, but it's better to work with. Your standard deviation. That measures variability directly. So let's take the root of the variance. So the root of the variance is the standard deviation. The root of 3 is equals to how much? That's roughly 1.7. So most scores, 70% of the scores, are within one standard deviation. So 70% of scores are going to be within 1.7. Remember, these are about 2. So here's my distribution if I have a variance of 3, or standard deviation of 1.7. Same thing over here for my other distribution. Now, comparing these side by side, you can see that they don't overlap in any way. They're very far from each other. This one is way down here. This one is way up here. That's if I went with A. What if I went to the other extreme and I went with D? So if we were to look at this other extreme of a variance of 16, take the square root in the same way we did before. Actually, let's make this easier to see. If we took the square root to get the standard deviation, so square root of 16 is 4. Once again, the majority of scores are going to be within one standard deviation. So if I were to do that, let's go back to our colors here. If I'm going to be within 4, that puts me with my first distribution looking like this, and my second distribution is going to be here, 2 below and 2 above. So 70% of the scores are going to be within this larger bar for the green and this larger bar for the red. Now these almost overlap. These two distributions, the green and the red, when I have a variance of 16 or standard deviation of 4, they appear to have become much closer to each other. And this is just 70% of the scores. If you consider the fact that there will still be the other 30% of the scores sort of coming out of the ends here, and the same thing for the green, the two distributions will actually overlap a bit. They won't look so distinctly different from each other. So it's when you're at this extreme, a variance of 3, that you're going to have the easiest time spotting the difference between the two of them side by side. So this one is very noticeably different from this one. So the answer is A, a variance, a sample variance of 3.